It's Wednesday. All right, today we're going to go ahead and do the second half of 9-5, solving nonlinear systems. Yesterday we did graphically. Today we're going to do algebraically. All of these have to have at least one nonlinear. For the most part, you're going to see a quadratic and a linear. That's because that's all we really can solve. You're not going to see exponential until Algebra 2. All right, so to do this, you're literally just going to solve them how you would solve any linear system algebraically by substituting one in for the other. Most of the time, these are already going to be in y equals. I'm not sure, I can't remember exactly how the delta math is set up, but if it's not set equal to y equals, then just make it equal to y equals. Okay, so I'm just going to take, because they are both set equal to y equals, I can just plug in one in for the other. So I'm just going to have a negative x plus 2 equals x squared minus x plus 2. And depending on how this quadratic is set up, you may want to do the square root method or quadratic formula, whatever you want to do. In the end, it doesn't matter as long as you can solve it. For the most part, I'm just going to generally set equal to 0. That's almost always my first choice, and then I'll move things around based on how it looks. So I'm just going to move these things over. So I'm going to get 0 equals, adding x cancels this x, subtracting 2 cancels this 2. You actually end up with 0 equals x squared. All right, this actually is the square root method. So I have an x squared isolated, so I'm just going to square root both sides, and I'm going to get absolute. So don't forget, we have that whole path. We do absolute x equals 0, positive, negative route, all that jazz. But when it equals 0, there's only one answer, so x equals 0. Don't forget that quadratics can have no solution, one solution, or two solutions. So just be careful, you might have more than one answer here. But you get x equals 0, so that is half my answer. So 0 comma something. Plug 0 into either equation. I recommend plugging it into the linear one so it's a little easier, but do whatever you want. Okay, negative 0, same thing as nothing, so 2. So y equals 2. Okay, you would check this answer by plugging in 0, 2. So plug in 0 here, you get 2 equals 2. Cool. Plug in 0 here and here, you get 2 equals 2. So just plug in this ordered pair into both equations, make sure it is correct, and that's how you check your answer. All right, number 2, also quadratic and a linear. Again, they're both set equal to y equals, so just set them equal to each other. So 2x squared minus 7 equals 7x minus 3. Again, by default, I just broke my phone. By default, I set it equal to 0. So I'm just going to move everything over to the left with my new pencil here. So I'm going to get 2x squared. I'm going to minus that 7x over, and then I'm going to add 3 over, so minus 4 equals 0. Here you can do whatever you want to. Obviously, you cannot do the square root method because I do have an x term there, but you could complete the square if you wanted to. You could do the quadratic formula. I'm just going to guess and check because it's a prime leading coefficient, so it's really not that bad. So I'm just going to guess and check. So I know in order to factor this guy, I would have to have a 2x and an x, and then it's either a 1 and a 4 or a 2 and a 2. Looking at the numbers, I imagine I'm trying to get an 8 and a 1. So I'm going to go ahead and put a 4 here and a 1 here. Inner product 1x, outer product 8x. Can I make a 1x and an 8x give me a negative 7? Why, yes, I want a negative 8 and a positive 1. So I did just factor that, but again, it doesn't matter at all how you do it. In the end, you're going to get two answers, okay? So I'm going to go ahead and set 2x plus 1 equal to 0. I'm probably going to run out of space. 2x equals negative 1, x equals negative 1/2. Okay, and this one's just x equals 4. So if you did the quadratic formula or whatever method you wanted to, you should get negative 1/2 and a 4 as an answer, which means that I actually have two separate answers. My answers are negative 1/2 comma something and 4 comma something. So I'm just going to go ahead and box off my answer there. So I need to plug in both of these and see what the answer is. So I'm just going to do that right here. Plugging in negative 1/2 into this equation, y equals 7 times negative 1/2 minus 3. Y equals negative 7/2 minus 3. Don't know why I put a parentheses there. So y equals negative, and that's a negative 3.5 minus 3. So y equals negative 6.5. So when x is negative 1/2, y equals negative 6.5. Okay, that's annoying that I just did decimals and fractions, but whatever. Negative 0.5 and negative 6.5 or negative 13/2, whatever. Okay, then go over and do the same thing for 4. Just going to plug in 4 for the same. I like to use the linear equation, but you could plug in 4 here. It doesn't really matter. But I'm going to say y equals 7 times 4 minus 3. Y equals 28 minus 3. Y equals 25. So I have 2 separate ordered pairs. So this means that I have some sort of quadratic, and my linear is crossing twice at this ordered pair and that ordered pair. So you have 2 different answers. I want to go ahead and show you how to check your answers. So again, you have that calculator emulator online, or you might have your own calculator at home. So to check that, just literally go graph those two. So 2x squared minus 7 and 7x minus 3. And then just go graph it. And the easiest way to actually graph it, or to check your answer rather, is just to press trace and just to plug in one of the ordered pairs. So negative a half, negative 6.5. So if you type in negative a half, it should give you negative 6.5. And this next one's off the window probably, so it may not do it. Oh, it did. So I plugged in 4 and it gave me 25, so that's correct. You could also just go to the table. You would need to change your scale so you could actually see that, but I can see that 4 is 25 across the board. So those are the 2 points where these two quadratic and linear are intersecting. All right, our next one is a linear, a straight across line, and a quadratic. They're both y equals, set them equal. So we get 5 equals negative x squared minus x plus 1. By default, I actually like to move my x squareds and make them positive, so I'm going to move everything to the left side there. So I'm going to get x squared plus x, and I would minus that 1, so I get plus 4 equals 0. Okay, and then there's nothing that multiplies before and adds to be 1. So this is not going to be a rational answer, so I do have to go ahead and do the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. X equals negative 1 plus or minus. This is going to be 1, and this is 4 times 4 is 16, so 1 minus 16 over 2. Already I know it's wrong, like it's not going to work out. 1 minus 16 is a negative 15. I cannot have a negative on the inside there. So this guy is going to be no real solution. If I graph this, these guys are, oops, I'm sorry, I'm off the screen there. These guys are not going to cross at all. So I'm going to go ahead and pause that and graph that real quick. All right, so I went ahead and graph both those functions there. Go ahead and graph it, and you see that they do not intersect. So there's no solution here. They do not cross ever. So no solution. All right, this is number 4. I actually already recorded it once, but for half the problem I was out of the screen. So here I am backed out so you can see all the work. Okay, so I have a linear and a quadratic, both set equal to y. So I'm just going to go ahead and set them equal to each other and check the screen repeatedly to make sure I am still in frame. Okay, set equal to 0, that's what I like to do. So boomity boom, boom, boom. Okay, you can do whatever you want to here. I'm just going to go ahead and just guess and check. Factor or whatever, because, well, I've already done it once and I know it works. But I would guess 3x and 3x, and I guess a 2 and a 1. Inner product 3, outer product 6. How do I make 3 and 6 become a 3? Well, I need a negative 3 and a positive 6, and that does give me my negative 2 sign there, so cool. Set both of these guys equal to 0. Again, you could do quadratic formula if you wanted to, or complete a square. Okay, add 1 to both sides, and then divide by 3, you get x equals 1/3. Over here, you're going to get 3x plus 2 equals 0. Subtract 2, you get 3x equals negative 2. Divide by 3, you get x equals negative 2/3. Hopefully that's not too fast, and just legit set equal to 0, solve, set equal to 0, solve. All right, what this means is that I have 2 separate answers. So I'm going to go up here and start out that answer. So we got a 1/3, comma something, and a negative 2/3. Comma something. Okay, then I'm going to scroll down so you can see what I'm writing. Also, before I do that, this actually means that I have a quadratic and a linear. Again, I'm going to have this sort of scenario where it's crossing 2 separate times, so I have 2 separate answers. Okay, so what I'm going to do is I'm going to go ahead and plug in 1/3 into my linear equation. So that was 5x minus 4, so 5 parentheses 1/3 minus 4. Y equals 5 times 1/3 is 5/3. I do want to change 4 so that it's divided by 3, so that's going to be a negative 12/3. And then 5 minus 12 is negative 7. In the screen? Yes. Okay, so negative 7/3 is negative 7/3. Okay, then plugging in the other guy in the screen where I can see it. Y equals 5 parentheses negative 2/3 minus 4. 5 times negative 2/3 is negative 10/3. Negative 4 can be converted to negative 12/3. Hopefully you understand how I did that. Just multiply by 3 on top and bottom. And then that's going to be negative 22/3. Okay, plug that guy in where he belongs. So negative 22/3. And I now have two terribly messy answers, but they are what they are. Two separate distinct answers with this quadratic and linear cross. You could check your answer by just plugging in 1/3 in for x, both these x's, getting a negative 7/3, 1/3 in here, get negative 7/3, and then do the same thing for negative 2/3 and negative 2/3. Just double check your answers if at all possible. Okay, number 5 is a word problem. I'm not going to read the entire thing verbatim, but Fabio drops the ball from a 520-foot observation deck, and it tells you the equation is negative 16t squared plus 520. I did not need to tell you that. You know that he's dropping, so there's no t value. Negative 16t squared is always existent, and then 520 is how high up he is. So he drops some sort of ball. At the same moment, Millie begins traveling up in a tower, and it travels at a rate of 12 feet per second. So Fabio's equation, I'm just gonna negative 16t squared plus 520. I need to figure out Millie's equation. So confusion often here is that she has some sort of fancy equation, but she's literally traveling at a rate of 12 feet per second. So she's just traveling at a constant rate, so just 12t. Set these guys equal to each other. Okay, set equal to 0. Okay, and this is definitely a quadratic formula, so I'm going to go ahead and set that up real quick. So I just plugged in negative b, so negative 12, plus or minus b squared minus 4 times a times c, all over 2a, that's 520. I'm going to go ahead and plug that in the calculator and show you the next step. Okay, so negative 12 is positive 12. Typing all that in the calculator exactly as is gives me this. 2 times negative 16 is negative 32. I'm going to go ahead and type it in the calculator again, and you're going to get two answers. I already went ahead and did them. You're going to get negative 6.09. Typing in the entire top thing, press enter, divide by negative 32. And do the same thing with a minus. 12 minus that, divide by negative 32. You get this other answer, which is 5.34. Okay, so you get two separate answers. The question was, at what time will Millie and the ball pass each other? So obviously I can't have negative 6 seconds, so it'll take 5.34 seconds for Millie and the ball to pass each other. Okay, hopefully I did not explain that too jaggedy, but I just found an equation for the ball, found an equation for Millie. Setting them equal is saying when their time is equal, when their height is equal. That intersection point, height and time will be the same. So I found the time to be 5.34 seconds. And then to determine the height at which Millie and the ball pass by each other, and you just literally take in and plug in, like this is a no repair. This is how long it took to pass, and then this is the height at which it passed. I'm just going to plug this into the easier equation. So m of t equals 12 times 5.34, and that is 64.08. So the height is 64.08 feet approximately. Okay, hopefully that wasn't too quickly, even though we have min and some change. All right, so you will have a question on Canvas similar to this one, and then you'll have some just delta maths. All right, hopefully you guys are doing great, and if you have any questions about anything, let me know. Otherwise, enjoy your minute of freedom. Yay!